Greetings everyone, today we will learn first chapter units and measurement. This would be the third lecture of this series. Chapter units and measurements. Lecture third. So, as we have seen in the first two lectures, we have discussed only units only, students. Now in this lecture I will begin to discuss measurements. So let's begin with significant figures. Significant figures. So the background story of significant figures is that while doing a measurement, you want to know what significant digits does the observation have. Okay. So the definition: the measured value of a physical quantity that tell number of digits which we are confident about. Number of digits which we are confident about. Okay, students? Yes, in which we are confident about. So I was going to write observation here. So that's the thing. So, sir, could you explain? This is actually measured value that I said earlier, that you have a length. Length is a physical quantity, and meter is the scale. And in meter scale, anything that you count in the meter scale, the numbers, and you are confident about your reading, that is the significant figure of the measurement. Okay, students? Now you would say, sir, now this explains us quite a bit about the experiment, but what if the significant figure or the number of digits in the observation is very high? What would you say then? Is the significant figure tell us that the observation is true then? So we would say yes. Larger the significant figures in a measurement, the greater its accuracy is. The greater its accuracy is. So this all you might have understood. Sorry. Now how to define a significant figure? That's the basic question. So how would you define a significant figure? Sir, by a number of digits. Yes, certainly, but that is not the proper definition of it. How to define a significant figure? Significant figure in a measurement. Think for yourself now. How would you define? Sir, you said about accuracy. So this would be the accurate values. Yes, definitely. But there is one step that scientists have taken ahead of us thinking, that they define a significant figure as, in a measurement, significant figure as all accurate values plus first doubtful. Okay, this is the basic definition of significant figures. So you remember what were accurate values? Accurate values were those values that we were confident about, and this is the first doubtful. So this makes significant figure in an observation. Yes. Example? Yes, sir. Please. Example. Suppose two rods. One being 2.53 meter, other being 3.10 meter. Now (3.1). So what is the significant figure of this number? 5.5. You add the rods and this becomes significant figure as 5.5 meter. This is a significant figure. So where is the 3? Significant figure. So where is the number 3? So as students, I have told that you take the first doubtful. So this is 5.5 is the first doubtful, and you don't take actually 3 here. Okay. Now the next part of this, rules of significant figures. Rules. First rule, all non-zero digits are significant. All non-zero digits are significant. Okay, students. Sir, this is okay, but little bit explanation. I will not give explanation of it. Rather, you would see examples. examples. So this would be better by example. 2, 3, 4, 4, 4 significant figures. Okay, students. 2.434, again 4 significant figures. 3.2, 2 significant figures. Okay. Second part of the story. Second rule. All zeros of between 2 digit, between 2 non-zero digits are significant. Yes, are significant. So this, sir, would you explain please? Anything between you have all zeros between 2 non-zero digits. So example you have 4.03. You see 0 is not actually here is important, but 3 actually making it very important here. So this is the thing. So 3 significant figures, 3 significant figures, 3 significant figures. Okay. Then you have 2.01. This makes 4 significant figures. Ending zeros. Third rule, ending zeros. Ending zeros. Ending zeros say after decimal plus end, after decimal plus end, ending zeros. So let me give examples of it. So those who might not have understood the second rule, it simply says you count the zeros, number of zeros between the 2 non-zero digits. That's the thing. The third part of the story, 540, ending zeros. How many significant figures? Beta 2. Students 2. What are they? 5 4 sir. 1 3 6, 3 significant figures. So what if, now suppose you write, let me erase this part for you. Another example, what if sir 2.40, Then what would you say, sir? Ah, you are making life tough for me. 3 significant figures. How, sir? Here, this here zeros were not counted. Here 0 is counted. You see, decimal had come, and after decimal plus and you have to count. Okay, so this is the basic definition. So, could you explain little bit more? So this 5.0, how many students? 5 significant figures. Yes, sir, we have understood this. Initial zeros. What was fourth rule? Yes, initial zeros. Initial zeros. Yes. Initial zeros, they are insignificant. Would you say what's how initial zeros are becoming insignificant? So you have a number 0.045. Okay. What are the significant figures here, students? Sir, 2 according to the definition. And what is it, students? 4, 5. Yes, these 2. So you don't count zeros here. Let me explain you why. So you might have noticed that 4, 5 or the number 0.00045 can be actually converted into powers. Okay. So powers, that is why, and 4, 5 can't be converted simply into the powers, negative powers of 10. So this makes 2 significant figures. So initial zeros are not counted. So what if suppose you say 0, 1, 2, 0, 4, 0. Now what would you say? This has 5 significant figures. Sir, how not 6 or 4? Because since this 5 I would take into account according to the definition that we have discussed. Powers of 10. Yes, completely fine. Powers of 10. Powers of 10. Powers of 10 makes 5, 10 to the power 5, 5 not, okay, 5 is a little bit easy. This would be, yes, we'll do 2 significant figures. 2 significant figures. So what are they? 5.6 beta, students. And second example is 30. So this would actually have 2 significant figures. No, students, this actually has 1 significant figure, 3. 1 significant figure, 3. One significant figure. This one significant figure. Now the last rule. Some many rules. Last one, 6 pure constants. This is the last rule. Pure constants, pure number, I would say. Pure constant is nothing. Pure numbers or constant. Pure numbers or constants. This is the last rule of the. Suppose we have Avogadro number. I'm writing this thing right. Avogadro number. So how many significant figures? Students, infinite. But sir, it has powers of 10. How? The powers of 10 are also included in this. Insignificant figures of constant, of any constant. If you see constant written anywhere after a number, it becomes, all the digits it have becomes significant figures. So does refractive index. Because what is refractive index? So it is a constant. So again, infinite significant figures. So see, same thing, infinite significant figures. Even the power 10 raised to power 8. Pi also, pi, infinite significant figure. So I will stop here. An example, rounding off. Now we will see rounding off. So it is not like you go around something, but rounding off. It is done for the first doubtful, rounding off. Rounding off. It is done for the first doubtful. It is done for the first doubtful. First doubtful. Sir, could you explain? So yes, examples are certainly very valid to explain your point. A round off these two numbers to two significant figures. Two significant figures. .46 becomes 2.5 and 2.27 actually becomes 2.3. Yes, this is easy. It is, we are getting this rounding off. But a little bit certain shift to the story. So what the shift is here? 2.25 becomes 2.2 only. So here it was 2.3, it remains here 2.2. Okay, now let me explain for you how this is happening. Consider 2.25 and 2.35, then this becomes 2.2 and this becomes 2.4. So how this remains 2.2 and this remains 2.4? This number 3, this becomes number 2. If the first doubtful is even, I should write first. If the first, double down. If the first doubtful is, what is students? Even. Is even, number remain as it is. If it is odd, you add +1. Okay, this is the thing. This is why it became 2.4. This remains 2.2. Okay, students. Rules for rounding off. And as you have noticed that 2.25 remains 2.2, but 2.27 became 2.3. So it actually, when you reach the 0.6. Now, even it has, rounding off has rules. So there's not much rules in it. First is addition, subtraction. Addition, subtraction. (2.42). This is the example. 1.32, 0.2. These are numbers we have taken. So what the significant numbers are here? 1.3, you are adding 0.2 and we get after addition, so 3.9, two significant figures. So where did this go? 2, 2. Students, we don't take into account the second doubtful. This is the second part of the story, and actually this becomes redundant because when you have in comparison numbers, you take the digits up to the point of the dot full of the lowest value. Here this becomes 0.2. Okay, so we take till 9 only, 0.9. Okay, you getting my point? We don't take into account 2 and 2 here. So, what about division and multiplication? So, don't discuss division multiplication. First, discuss subtraction only. So, subtraction case 14.5, 3.28. I'm not putting many numbers here because what I want to teach is not subtraction but the method. 3.28. So actual number is 11.2 after subtraction, but it has only 3 significant figures, this 3. Multiplication and division. Multiplication and division. So this would be the same thing, in the same manner. Yes, but the examples would be different, completely. Tough, I would say. 0.12. So we don't know the word tough. 0.12. This becomes 0.744. What are the significant figures, students? So, of course, it is 74, two significant figures, 0.74. Again, the reason 6.2, because of 6.2, two significant figures here, two significant figures here. So, this becomes two significant figures. Okay, sir, we got your point, but suppose, sir, let's make sir life tough here. 5.6, 0.2. These are the two numbers you have given me. And what it is? 5.6, 0.2, 1.12 is the number. Okay, 1.12. What are the significant figures, sir? Actually, sir, it has only one significant figure. That is one only. One significant figure. You don't take into account 0.12, just the one significant figure. So, but here two significant figure, here only one. So you take into again the count one significant figure. So what about division? So division case 48.36, the numbers and 12. So this is the example of division. 48.36 upon 12. So you are dividing the numbers. What are the significant figures here, students? So 4. You should not actually ask now. 12, 2 significant figures. 2 significant figures. This makes what is, students? Sir, 4.03 after division. Yes, very good, very nice. You divided very well. What about the significant figures? So 4.0. You are getting sharp. 4.0, 2 significant figures. Yes, very good. Now numerical part. So theory part ends. 4.0. These are the significant figures. Theory part ends. Let's see numericals. Somebody is saying we were waiting for it. So let's see numericals. Find the number of significant figures in following. First 0.40, second, you keep thinking yourself, 2.346, 3, 2.50 into 10 to the power 4. 0.0542. Fifth, 0.0640. Sixth, 56002. Seventh, 56.0. Eighth, 159th, 5601. Yes. Okay. Yes, sir, we have understood this part, but since they are numericals remain numericals, you apply the theory. Okay, sir. Solution. So first is 0.40. This has 2 significant figures. First part has 2 significant figures. Yes, sir, my answer was right. And what it was? 40. These were the 2 significant figures. Second, being 4 significant figures. What were they, students? Sir, 2.3, all of them, sir. 2, 3, 4, 6. third. How many significants? Sir, 2. I actually have written a wrong number here. 250 is the thing, and this should be 3. 3. Actually, this would again repeat here, so it is not the right thing. Maybe. Oh, yes, it is point. I didn't notice. 3 significant figures. What are they? 250 and fourth. 4 significant figures. 3 significant figures. 3 significant figures. What are they, students? So 542 significant figures. 542. Fifth, 4 significant figures. So what are the 6400? Sixth part, 560 to 5 significant figures. 5 significant figures. What are they? 56002. No. 56. How many, student? 56. Sir, 4. Yes, very good. What are they? 5600. Actually, you don't say 00 here. You say 00. After decimal, 4 significant figures. 56.00. What is the 8th? Yes, 150. So 2 significant figures. 2 significant figures. So you have written 2 significant figures. 15. Now the last part of the story, 9th. How many? 3, sir. Very good. Now you are an expert. 156. Okay. So yes. Oh, this is not 1. This is 560. Certainly, I am mistaken here. 56. 2 significant. Yes, certainly. Okay. Yes. So this numerical part will do everything. I will stop here. Thank you.